This is Mrs. Zappia with Lesson 7, Classification of Solutions. Student outcomes for this lesson. Students know the conditions for which a linear equation will have a unique solution, no solution, or infinitely many solutions. The purpose of this lesson is to point out the characteristics of the constants and coefficients of an equation that allow students to see the structure in equations that lead to a unique solution, no solution, or infinitely many solutions. Pause the video and copy the essential questions. There are 3 classifications of solutions to equations. What are the characteristics of each? Pause the video and solve each of the following equations for x. Solve 1, 2, and 3, and then resume the video. Was there anything new or unexpected about exercise 1? We solved the equation for x, and x equals 4. What can you say about the coefficient of terms with x in the equation? The coefficients are different. Do you think any number other than 4 would make the equation true? Pause the video and consider this question. Instead of having to check every single number to see if it makes the equation true, we can look at a general form of an equation to show that there can only be one solution. If the coefficients of x are different on each side of the equal sign, then the equation will have one solution. It's time to begin formalizing what we have observed as we have solved equations. To begin with, we have learned that some linear equations have no solutions. That is, when we solve an equation using our properties of equality and end up with a statement like a equals b, where a and b are different numbers, we say that the equation has no solution. Let's take a look at number 2. Depending on your first step, you might have gotten a result of 0 is not equal to 8 or -3 is not equal to 5. When you end up with a statement of a equals b, let's change that to a pen. And a and b are different numbers. We say that the equation has no solution. Contrast this with the first problem, where you have one unique solution. In problem 1, x equals 4, and 4 is the only number that will solve that equation. In number 2, there is no solution. To produce or recognize an equation with no solution, consider the equation with both sides simplified. The coefficients on the variable x will be the same on both sides of the equal sign, and the value of the constants on each side are different. This type of equation has no solution because there is no value of x in an equation such as this that will make an equation true. Let's take a look at problem 3. Was there anything new or unexpected about exercise 3? When solving this equation, we get -3 is equal to -3, which did not give us a value for x. When solving the equation, we got 7x equals 7x, and we weren't sure what to do next, or what it means. Is negative 3 equal to negative 3? Yes, it is always true. If 7x equals 7x, will we always have an equality, no matter what we choose for x? Yes, we will. Because if you multiplied by 1, you would get the same answer. If you multiplied by 2, you would get the same answer. What if you chose a negative number? They would still be equal. What if you chose a fraction? They would still be equal. This is called an identity because the same expression is on both sides of the equal sign. What can you say about the coefficients of the terms with x in this equation? The coefficients are the same. What can you say about the constants in this equation? The constants are the same. We know that there are equations that produce statements that are always true. That is, negative 3 will always equal negative 3, 0 will always equal 0, 7x will always equal 7x, no matter what number x happens to be. When we solve an equation using our properties of equality and end up with a statement like A equals A, where A is a number, then we say this equation has infinitely many solutions. Infinitely many solutions. To produce or recognize an equation with infinitely many solutions, the coefficients on the variable x and the value of the constants will be the same in the simplified expressions on both sides of the equal sign. This type of equation has infinitely many solutions because any value of x in this equation will make the equation true. The left side of the equation will be identical to the right side of the equation, and it will look like this. X plus a equals x plus a. Let's take a close look at the equations we just talked about and take a look at the coefficients and the constants, because that is how we determine what type of a solution the equation will have. In the first problem, the coefficients are different and the constants are different. What kind of an equation will that be? When the coefficients are different and the constants are different, this will result in one unique solution. Why? Because the coefficients are different. In the second problem, let's take a look at the coefficients. The coefficients are the same. The constants are different. The coefficients are the same. The constants are different. This type of an equation has no solution. Why? Same coefficient, different constant. In the third problem, let's take a look at the coefficients. The coefficients are the same. The constants are the same. We have the same coefficient and the same constant. This type of an equation has infinitely many solutions. Why? They have the same coefficient and the same constant. You may be wondering why in the first problem I didn't talk about the constant. When you have one unique solution, the constant is irrelevant. It doesn't matter if it's the same or different. Let's go to the summary and copy some information down. There are three solutions to linear equations, or rather three types of solutions. There is a unique solution where x is equal to 1 and only one number. After simplifying the left and the right side, you have a different coefficient of x. And an example is 4x plus 7 equals 2x plus whatever. Remember, the constant doesn't matter when there is one solution. The second type is no solution. When there is no solution, after simplifying the left and right side of the equation, you'll have the same coefficient of x and different constants. This will give you no solution. For example, 3x plus 7 equals 3x plus 2. The third type of solution is infinitely many solutions. After simplifying, you'll have the same coefficient of x and the same constant. For example, 6x plus 7 equals 6x plus 7. Remember, infinitely are identical. The left side matches the right side. Pause the video and make sure that you copy down the lesson summary. This is an important topic and you'll want to memorize these characteristics of solutions to linear equations. When you're ready, go back to page 51. On your own, give a brief explanation as to what kind of a solution you expect the following linear equations to have. Transform the equation to a simpler form if necessary. So taking a look at the first equation, notice that it is not in simplest form. First, simplify the left side of the equation. Then, simplify the right side of the equation. Then, look at your coefficients to see whether they are the same or different. Then, look at your constants. Are they the same or different? Then, determine what type of solution you will have. Then, explain why it is that type of solution. Pause the video and complete number 4. In simplest form, the equation is 9x plus 15 equals 15 plus 9x. The coefficients are 9. The constants are both 15. This will have infinitely many solutions. Because the left side and the right side are identical, you have the same coefficient and the same constant. Pause the video and complete number 5. Simplify and determine what kind of an equation it is by completing the problems on the right side: coefficients, constants, type, and y. First, use the distributive property and then simplify. The types of coefficients are different. The constants are different. So this will result in one unique solution. Why? Because you have different coefficients. Pause the video and complete number 6. Simplify the left and the right side of the equation. You get negative 10x plus 32 equals negative 10x minus 20. The coefficients are the same. The constants are different. This will result in no solution. because they have the same coefficient but different constants. Pause the video and complete number 7. First, use the distributive property, and then I just rewrote the problem so that using the commutative property. That helped me to identify my coefficients and my constants. They're both the same. This equation will have infinitely many solutions. It has the same coefficient and the same constant. When the left side is identical to the right side, identical means infinitely many. Number 8. Write 2 equations that have no solutions. First, write down the characteristics of equations that have no solution. What do you know about their coefficients? What do you know about their constants? Pause the video and complete the right side of number 8. We know that their coefficients will be the same. We know that their constants will be different. This will have no solution because the coefficients are the same, but the constants are different. Pause the video and write 2 equations that meet these criteria. Number 9. Write 2 equations that have one unique solution of each. First, fill in the information on the right. What do you know about their coefficients? Their constants? We know that their coefficients will be different. We know that their constants, it doesn't matter. They can be the same or different. Their coefficients will be different, and that's what makes it one unique solution. Pause the video again and write 2 equations that meet the criteria for one unique solution. Question 10. Write 2 equations that have infinitely many solutions. Pause the video and write down what you know about the coefficients and the constants when there are infinitely many solutions. The coefficients will be the same. The constants will be the same. Pause the video and write 2 equations that have infinitely many solutions that meet these criteria. We know that these will have infinitely many solutions because they have the same coefficient and the same constant. We know that they will be identical on the left and right. In this lesson, you have learned to classify solutions to linear equations. A unique solution where there is one and only one number that will satisfy the equation. After simplifying, they will have a different coefficient of x. For example, 4x plus 7 equals 2x plus any number. The coefficient is different and the constant doesn't matter. That will give you one unique solution. When there is no solution, after simplifying, you will have the same coefficient of x and different constants. For example, 3x plus 7 equals 3x plus 2. Infinitely many solutions means that any number will work and satisfy the equation. Infinitely many, after simplifying, you will have the same coefficient of x and the same constant. For example, 6x plus 7 equals 6x plus 7. Any number will satisfy this equation. Remember, for infinitely many solutions, the left and the right are identical. Infinitely are identical. You will want to memorize the characteristics of linear equation solutions.